Find the center, foci, vertices, eccentricity, and sketch of 9x squared plus 4y squared minus 36x plus 8y plus 31 equals 0. Since this conic section is in general form, the first thing we want to do is get it in standard form by completing the square. So we'll start by grouping the similar terms together. So we'll start out with the x's, 9x squared minus 36x, and then the y terms, 4y squared plus 8y, and then the constant term we can move to the other side of the equation. Now to complete the square, we can't have a leading coefficient on the squared term. So for the x's, we'll factor out the 9. This leaves us with x squared minus 4x, and then we'll leave some room for completing the square. For the y's, we do the same thing. We factor out that leading coefficient of 4. This leaves us with y squared plus 2y, and then we'll keep the right-hand side as it is. Now to complete the square, we take half the coefficient of the middle term. So in this case, that's negative 2. If we square that, that's positive 4. Now we just added 4 times 9 to this side of the equation. So we'll add the same to the right-hand side. Let's do the same thing with the y's. We take half the coefficient of the middle term, which is positive 1. If you square that, that's positive 1. However, we just added 1 times 4 to the left-hand side, so we have to add 1 times 4 to the right also. Now we can factor. This trinomial will factor up as x minus 2 squared. And then the y trinomial will factor up as y plus 1 squared. On the right, we can combine like terms, and we get 9. So this is shaping up as what looks like an ellipse. We have a x squared term plus a y squared term. So we need a 1 on the right-hand side. To do that, we'll divide both sides of the equation by 9. So then on the left-hand side, I see these 9's will reduce to give us x minus 2 squared. There's no reducing here, and we can't have any coefficients, so I'm going to swing this 4 to the denominator and write this as y plus 1 squared over 9/4. On the right-hand side, these reduce to give us 1. Okay, so now we can identify what all the pieces are. H is the number being subtracted from x, so I see that h is 2. K is the number being subtracted from y, so k is negative 1. In an ellipse, a squared is the larger of our two denominators. So I see that a squared is 9/4. So taking the square root, we have a is 3/2. B squared is the smaller of the two denominators, so b is the square root of 1, which is 1. And then to get c, we have this formula, a squared equals b squared plus c squared. We'll fill in what we know. A squared we know is 9/4, b squared is 1, and c is what we're solving for. So if we subtract 1 from both sides of the equation, we've got 5/4 equals c squared. Taking the square root, we get that c is the square root of 5 over 2. Now that we have all the parameters, we can start filling in the missing information. So they ask first for center. Now the center is the point h comma k. We've identified h and k, so this is 2, negative 1. Now the foci, we have to go in the direction of the major axis. Now the larger of our two denominators was under y. So we know the ellipse has to open upward. Right? It's going to be a tall ellipse rather than a wide ellipse. So from our center, which is at 2, negative 1, we're going to go upward by c units. So we're going to go up radical 5 over 2 units. So that says we've got 2 and then negative 1 plus radical 5 over 2. And we've got to go down radical 5 over 2 units to get to the other focus. So this will be 2, negative 1 minus radical 5 over 2. So those are our two foci. The first one was 2, negative 1 plus radical 5 over 2. And the second focus was 2, negative 1 minus radical 5 over 2. Next up, the vertices. So these are the furthest points on the ellipse from the center. So we see that we have to go all the way up a units to get to the first vertex. So we're going to go up 3/2 from our center. So this will tell us this is 2, negative 1 plus 3/2 for our top vertex. And the one on the bottom, we're going to go from the center down 3 over 2 units. This is 2, negative 1 minus 3 over 2. And then find the eccentricity we have a formula for. And this is that eccentricity is c over a. C we've calculated already as radical 5 over 2 divided by a, which we have as 3/2. So we can flip and multiply here. We can write this as radical 5 over 2 times 2 over 3, and these will reduce to give us radical 5 over 3.